Alright, in this lesson we're going to be looking at lesson 6.8, chapter 6, lesson 8, and we're looking at multiplication properties. This is very similar to our addition properties where we have our associative property and our commutative property and our identity property, but now we are just looking at multiplication as our operation. So let's look at our first example here, where a coach had 16 players in two groups, and let me get my pen to be able to move. There we go. There we go. A coach had 16 players in each of two groups. Each player scored 5 goals. Find the total number of goals scored. So if I were to set this up, I have 16 players in two groups, so 16 times 2, and each player scored 5 goals. So since we can multiply 2 and 5 easier than 16 and 2, I'm going to regroup them. So this would be where I then take my numbers and I regroup them. So before I had 16 and 2, now I'm going to group 2 and 5 because that's easier to say. 2 and 5 is 10, and powers of 10 multiplying by 10, 16 and 10 is 160. Now that is our associative property because I am changing the grouping. Now if I were to look at our commutative property, just like in our commutative property of addition, I am moving the number from one spot to another. So if I have 35.5, 35 and a half times blank, we'll call that, now again, we have an unknown there, so we can call that a y, or an x, or an a, whatever it is. It's a variable. We're solving for the unknown. So 35.5 times an unknown, we'll call that y, equals 17 times 35.5. Well, for them to equal each other, we have to have the same numbers on both sides. So the unknown number is 17. All I'm doing is moving the 17 from the second digit, or the second number here, to being the first one. So 35.5, if we looked at that, that would be like our first number, and 17 is our second one. Now 17 is our first one, and 35.5 is our second one. So all I did was change the order. So again, our commutative property, this is looking at a change in order. We'll get the same answer. And lastly, our identity property. And this is one quick one that some people, common mistake, is they think of their identity property of addition and say, oh, well, that's 0. Well, with multiplication, if you multiply it by 0, you're not going to get the same number. You're going to actually get 0 because anything times 0 is 0. So find the unknown in the equation. 17 times what? Again, we'll call that, well, let's call that t. For an unknown variable, 17 times an unknown equals 17. Well, the only thing you can multiply a number by and get itself is 1. So the unknown factor is 1. Identity property of multiplication means that we are multiplying it by 1. So let's look at some examples here and draw lines to connect which one is which. So 6.2 times 100 equals 100 times 6.2. Well, what changed here? Hopefully you identify that we have changed the order. So that is our commutative property, the order change. Now 8 times 2 in parentheses times 3 equals 8 times 2 times 3 in parentheses. So again, what changed here is our grouping. So that would be our associative property of multiplication. And then lastly, this is one that should stand out when we see times 1. That should say, hey, we're talking about the identity property of multiplication because we're multiplying by 1. Again, associative is our grouping, commutative is our order, identity is when we multiply by 1. So let's do some practice real quick. So use the properties of multiplication to find each product mentally. Now this is so that we can easily break it down and better answer a problem without having to do all the work. Now we're going to have to do some work still, but the idea is to be a good mathematician, and that means rearrange it, do problems in an easier way. So 5.1 times 2 in parentheses times 50. Well, I could regroup this and say, well, 5.1 times, and I could say 2 times 50. So now I have used my associative property, and I get 100 for 2 times 50 because I have to do the parentheses first, and then 5.1 times 100. Well, when I multiply by 100, again, 5.1, I'll do that over to the side, 5.1 times 100, I'm going to move my decimal point over the same number of times I have zeros. So I have 2 zeros, so I'm going to move it to the right, 1, 2, and I fill in the gap with 0. So now I have 510. So our answer is 510. Again, if we look at our next one, we have 4 times 2.5 times 6 with 2.5 times 6 in parentheses. I'm going to regroup them and say, well, 4 times 2.5, and I'm going to put that in parentheses, times 6. Think of money, 2.5 times 4, well, that would be 10, right? So if I took 10 times 6, I would get 60. Again, I've used my associative property. If I were to look at 9.8 times 500, in parentheses times 2, again, I'm going to regroup it. 500 times 2 times 9.8. The order stays the same. I've just regrouped what the 500 is grouped with, or who it associates with, and I get 1,000 times 9.8. Again, I count my zeros, 1, 2, and 3, and since it's 1,000, I'm going to move my decimal point 3 times to the right. So 9.8, 9.8, I'm going to move it 1, 2, 3, fill the gaps with zeros. So my answer is 9,800. Let's get rid of our loops. Now we could show that, that's no big deal, but just so that you're not confused as to where it's actually at. And then 1.4 times 50 in parentheses times 2, or I'm sorry, times 20. I'm going to look at this and say, well, 50 and 20, that's easier to work. So 50 times 20 in parentheses, and then 1.4. 50 times 20 is going to be 1,000. I could look at my basic problem here and say, well, 5 times 2 is 10. And then I count the zeros. I've got 1 and 2, so 10. And then I've got 2 zeros, so 1,000. And then 1,000 times 1.4. Again, I have 1, 2, and 3 zeros, so I'm going to move it 3 times to the right. So 1.4, 1.4, 1, 2, and 3. I move my decimal point 3 times to the right. I get 1,400. Again, all of these are dealing with our associative property. And this is one of the more challenging ones, is to regroup our numbers so that's easier to do. So let's now look down and say, well, if I were to break down our problem here and say 19.5 times what equals 19.5? Well, the only number that you can multiply to get the same one is 1, so that means we are looking at our identity property. Oh, and let's circle, right, because that is what the directions say. All right, 34 times 65 equals 65 times what? Well, again, I need to get the same answer because they are equal, so I have to use the same numbers. So that means this is going to be 34. What changed? The order. So that is our commutative property. Not to be confused with community. There's no N in commutative. And 2.1 times what equals 4.3 times 2.1? Well, the missing number for these two expressions that equal each other, this needs to be a 4.3. So 4.3 is our unknown. All I changed here was, again, the order. So that's our commutative property of multiplication. And 17 times 2 times 5 equals 17 times what equals, or 17 times, in parentheses, what times 5? Well, I have to have the same digits, same numbers I'm working on my problem. So this is going to be 2. And all I did change was the grouping of it. So that is our associative property. Hopefully this rings a bell and connects you with what you did with our addition properties. Let me know if you need help. Otherwise, this is the end of lesson 6.8.